Everyone who's just joined if you've just joined the session, I'll introduce what Shadow the Scientist is about and what we're doing tonight. But please bear with us for a few minutes. We'll wait to see if any others join. Hi, Yash. Elisa, are there particular papers you're working on right now?
Well, very far from papers. So I'm doing, do you remember these observations that we did with Dave Sand in VIMOS?
Of
VLT,
which galaxy, Sene?
Sene, the stream that
Oh,
Dania discovered. So the main issue with that is it was that we didn't know how to use the VIMOS pipeline, and because it has been decommissioned, so the expertise is like
gone, yeah.
gone basically. But we found a postdoc that knew how to do that.
I see.
So he did the data reduction and yeah, and gave me everything. So I am looking at the data, but so we'll see. We'll see. Because
1D spectra. 1D spectra.
1D spectrum. So the main complication that I am finding is that when there is no continuum, the extraction window, I don't think it is centered on the coordinates of the target, but it is completely on the edge of the slit. So then the automatic extraction is not really working. So yeah, complicated. And I am not sure if the 2D spectrum it is calibrated with coordinates or is just pixel positions. So
I see.
So right now I just I figure out how to use the data, which is as usual, nothing I have used before, and there is no documentation. So I have had to figure it out with trial and error. Took a while, but now I inspected all the 2D and 1D spectra. So I am ready to start some co-addition and do some tests.
Okay.
Yeah. Yeah. We do not know the resolution, so I will have to measure resolution in skylines also.
I see.
Or yeah. So
Stuff.
it's a complicated project with very low signal to noise. So it's not gonna be a very exciting paper, but it's gonna take a very long time to.
First measurement. The first measurement. These things
Yeah.
are hard to do.
Yeah.
Um,
So I think that the velocity and radial velocity, there are a few continuum that I see. I'm hoping that some of them are not Milky Way stars. So at least we can get radial velocity for the
mhm.
stream. Not sure if we are gonna be able to get a gradient, but well, we'll see. Maybe a couple of points.
Okay. Lisa, I'm going to share my Xterm screen with you.
Mm-hmm.
It might be useful for me to set up my VNC.
Okay.
I don't remember the instructions. Do I need anything from the Keck folks or not?
You need this key to access the SSH, that is the API.
And they have to send it to me.
You uploaded it in the in the Keck observers login, and they accepted it at some
But
point.
the old laptop, though, for the new one, I would have
Yeah.
to
So for
redo
the
it.
new one, you may need then a new one.
Mm.
I don't know.
Is the API specific to a laptop, to a person?
That I don't know.
We can try. I mean, I copied over all the software from, sorry, like all the data from the old laptop to the new one. So maybe it'll just work. I could try that.
Just try that.
I want to share my screen.
Mhm.
Hi, everyone. I'm just going to introduce the group and how much time left for this exposure?
Like 400 seconds or so.
Okay, so so over 6 minutes.
Mhm.
Hi, everyone. If you have a minute to type into the chat how you found out about STS, Rob, of course, I know you. How about Josh? I know you found out from our class. Um, if others would like to tell us how they found out about STS in the chat, that would be great. STS being Shadow the Scientist. Um, and in the meantime, I'm going to share my screen with Elisa so we can troubleshoot or we can figure out how I can have the students view my screen. So I'm starting up an Xterm window. I have a directory called Pajama Observing Keck. See, I've got my VNC viewers. KCWI5.
Yeah.
Does that command look correct?
Yes.
Oh, I have to do
When I do that, I have to launch Astroconda first.
exactly what do I do? How do I do this?
Source activate Astroconda. Is that what you
Exactly.
use?
Yeah, that's what I do. Is it Astroconda that you use?
That is the one I use.
Like that.
Astroconda. Yes. Okay. You do not have Astroconda.
Um, I had something else. I had source activate KRO, Keck Remote Observing. What do I do? So this is the problem, Elisa. Unable to verify remote version. I was showing my class this James Webb paper. Is Guillermo on the Jades team?
Sears, I think, yes.
Is he? I guess we observed the supernova last night, right?
Yes, we did.
See. Stop my screen share for a minute. For the folks who are on the call, Dushyant, Ankit, Akanksha, Kritika, Kanika, and Dushyant again. Where are you connected from? If you could write your country or city, that would be great. And how you found out about SIP, you could put that in the chat, that would be great. Or at least what time of the day or night is it for you? Are you based in California? Rob, I know the answer for you, and Yash, I know the answer for you. That's why I haven't asked. Lisa, is it about 3 minutes left now? Less than that.
It is about to
About
finish.
finish. I see.
I'm gonna get ready to tell Tony to move the telescope.
So it doesn't look like I'll get VNC working later, but right now it doesn't look like I can get to screen share.
Okay.
I've given everyone permission to unmute and turn on video if they wanted to say who they are, but
Okay.
new exposure started, Sky?
Yes. Oh, yes, that's that.
Or was the sky that just finished?
Yeah, the sky just finished. I started target.
I see.
Mm.
I can bring up the picture of the ultra-diffuse galaxy that we have in our Best Shadow the Scientist page.
Can I have two Zoom sessions simultaneously?
I
I don't
see.
think. Hmm?
Sorry?
Can I have two simultaneous Zoom sessions?
On the same computer? Probably not.
Probably not. Yeah.
I've never been able to do that on one computer.
Yeah.
The computer where you're running VNC, that doesn't have Zoom, is it?
Yeah, I'm connected with the summit. So that's why I don't want to disconnect from that Zoom.
Yeah, I see. I see. Dushan, thank you for for letting me know. GD Birla Memorial School in Raniket, Almora. Where is which state is Almora in? Yeah, at least I'm trying to brainstorm about. I mean, I can of course show other. I can show other UDG things I can show. We have your UDG paper. Uttarakhand in India. Thank you. Should I'm happy to bring up your paper.
Mhm.
Let me see if I can do that. So I'm still bringing up your paper. Just give me a moment.
Mhm.
It was your paper on ultra diffuse is what I'm thinking about.
Okay. Mhm.
This is your dark matter and the ultra diffuse galaxies in the Virgo cluster from the globular cluster population. Not that one, right? That's 2018.
Yeah, no. This is 2023, I think.
I see 2023, okay. This is NGVS paper 35, right?
Yeah.
I've got your paper, Elisa.
What?
I said I've got your paper pulled up. Looking at the chat. Yash, what has happened since the last meeting and now is the sky has been clear. Elisa and Eric were working away, collecting more photons from the same galaxy just to build absolute noise. That's what's been happening. Nothing exciting. Everything is going just like they were at the previous STS session. And I've given everyone permission to unmute and speak, so you should be able to unmute. If that's easier, whatever's easiest.
Hi, Professor. Can you hear me?
Yeah, of course, go
Yeah.
ahead.
Will we be able to see any of the pictures?
Say that again.
Will we be able to see any of the pictures?
So that's what we're struggling with because I'm not being able to see the control software directly. So one way to do that is to invite this group to join a different Zoom call. That's the only way I can think of right now. Because right now, I'm not able to see it. Elisa is able to see it, but from a different computer. And we have to maintain a connection with the summit crew, the person at the Summit of Mauna Kea.
Oh, okay.
So let's see if we can figure out something.
Yeah.
So when I first joined, what I was doing early in the evening, I had connected you guys on my phone, and then my laptop was on the shadow session. That's one thing that's one workaround is. But you're using two different laptops, right?
Me?
You're using two different laptops, Elisa?
Yeah, well, one is a desktop and the other is a laptop, yeah.
I see. So I could do that. I could connect. Actually, let me check something. I can leave briefly and I can ask Tony if he would be willing to connect. I can send him a Zoom link.
Okay.
Let me see. Because if he's able to connect,
He can do the sharing the.
he may not be able to do the sharing still. But then you don't have to run two Zoom. Let me ask him. I'll make you a host for a moment, Lisa.
Okay.
Come back. I've made you a host. I will leave and come back. Hi, Elisa. Hi, Tony. Elisa, are you able to give me co-host permission, please?
How do I do that?
Just click on participants.
Where?
If you click on participants next to my name, you can
Okay.
make host. I don't know if you can.
Make host. Okay. There you go.
So folks who are on the call, I wanted to show you a paper that Elisa wrote recently on these kinds of galaxies that we're studying tonight. So I can't share the instrument control software, but we can look at the paper. How many galaxies were in this paper, Lisa? How many UDGs?
10.
10 UDGs. Okay.
Yeah.
Lisa, what are the numbers in the unified astronomy thesaurus concepts? What are the numbers in parentheses?
Which numbers?
In the at the right after the
Ah, is the code.
so
Yeah, no keywords have codes, numerical codes.
this was a Demos paper, not KCW. Right? Those are the 10 galaxies. VCC 615 is the paper that Chris Smihos has been writing papers on.
6:15, yes.
Oh, these are the galaxies I see. Wow. Beautiful. Are we observing any of these tonight?
Yes, 19, the one that is isolated in the middle row, the last one.
Far left.
Yeah, far right.
Oh, 19. See, far left. So 20 looks like it's really low surface brightness, 20 and 11.
Yeah. Those we cannot observe. That's why they are not in our list for this proposal.
Project. What is the red line at the center of 11?
Oh, those are globular clusters, one next to the other. They're very close together.
Well, many of them have very bright stars, Milky Way stars close to them.
Yeah.
10 in particular. Oh, I see. These red markers that's just a line of globular clusters. I see what you're saying. Oh, there's Aparajito. Hi, Aparajito. Hi, Aparajito.
Hey Raja,
How are you? I had a nice meeting with Liv yesterday.
yeah,
Sorry I didn't record it, but we have something better. Liv and I are writing up a Google Doc about next steps for the Bells project. And
right.
there's an undergraduate at Santa Cruz who's keen to learn about this. We have some interesting ideas. Bob, Gabe, Liv, and I talked for about an hour yesterday in my office. And initially, it was just the three of us talking. We had forgotten to connect on Zoom. So by the time Liv joined, I forgot to record. And so I will be, Liv will start a Google Doc. We'll share it with everyone. In any case, the conversation was introductions and things like that. So it was a little bit more diffuse. So the Google Doc will write down the exact things that I can summarize a few things.
Well, I read the paper you shared the other day. Read as in, well, you know, the abstract, the introduction and the conclusions. I didn't focus too much on the methods, but maybe we should take a look at that. Maybe it will help us identify our ultras. I don't know.
Yeah. So one of the things we want to do, and these are again things we'll put in the Google Doc, is we want to. That paper is from 2011. It's 13 years old. We want to find out what the state of the art is of Wolf-Rayet stars in M33. Are there newer papers? Are there bigger samples? We need to That's one question, just an open question.
Right.
Even if there are newer papers, there may be newer information on the same stars as opposed to a bigger sample of stars. These
Right.
are, again, we don't know. Whatever the
Yeah.
sample,
I think they surveyed some 200 odd stars.
yeah, about 200
yeah.
stars, exactly. One of the things we want to do, whether it's with that old paper or if there's a newer sample, is it would be, we have HST photometry over the entire region. So it would be good to see where the Wolf-Rayet stars land in HST CMDs. I don't think anyone's done that before, but I can check with Ben Williams to see if anyone is doing that.
Okay. Yeah.
And while that does not involve the Bell spectra, it is putting Wolf-Rayet science in M33 on a more modern footing, because instead of using ground-based images and ground-based photometry, this would be HST photometry. So I was thinking we can make...
Right. And I wonder if I remember correctly, they used photometry to select the first set of suspected Wolf-Rayet stars, Wolf-Rayet candidates. So I wonder if HST, if we look at the HST results, HST photometry results, and if we recognize some kind of pattern in the HST photometry, if we can use that to identify more Wolf-Rayet through HST photometry. Because
exactly
the paper,
right.
yeah, because the paper points, as the paper points out, it's not easy to find the WN Wolf-Rayet, which is where they made a major improvement, I think, in detection. But again, they were working with ground-based data, so probably we can improve on that with HST.
Well,
maybe it's more sensitive.
HST is certainly more sensitive, and it has more sensitive in the sense of more precise photometry for stars, but also higher angular resolution in crowded regions, all of those things. However, the way they found them is through not using broadband filters, but narrowband filters.
All right.
That's how the Nugent and Massey used narrowband filters, imaged M33, and then found, if you put a narrowband filter, if the filter is narrow enough, you can look for stars with emission lines, H-alpha emission line. That's how they did it.
Right.
We don't have anything like that with HST.
Yeah, something else that I noticed in the paper is that I didn't know about before is that there was, at least at the time the paper was published, there were some conflicting results about the metallicity gradient in M33.
I see.
Which is, which is something which was one of the goals of their project, to kind of find some clues about the metallicity gradient, specifically the oxygen metallicity gradient in M33, as in the radial gradient. And they used the WC to WN population ratios to kind of find some clues for that. But because that seems to be a really good marker, and it works really well for LMC and SMC metallicities for Wolf-Rayet and those galaxies. But yeah, it's interesting. I don't know how much research has been done since, but that seems like something that could relate to the WISS project, which again, I literally brushed up some old code like yesterday. And I don't want to, I don't know, I'm not going to plan too much right now. I think we need to bring it all together first and then see where it goes. I'm also holding off on my decisions to mentor for SIP this summer until I kind of have a sort of a plan for the project. And then, yeah, of course, I would like to talk to you about it and see how we can set up the project. If we can do maybe in person this year. Yeah, I was considering that. I don't know. But yeah, first, the project needs to be, it doesn't need to have a plan.
Yeah. We are encouraging the students to come to campus, the high school students to come to campus this summer.
That's great. That's
Would
great.
you be able to come to campus, you think, this summer?
If I do end up mentoring, again, I really want to chalk out the whole plan, like at least a rough plan before I commit to it. If I do, let's say there's an 80% chance that I want to. But yeah, I have to think about the logistics about, getting a visa in time. And yeah, we'll talk about those details later, I suppose.
Yeah,
but yeah, I really want to. There's a good chance that I'll be there. Let's just say that.
That's great. That's good. That means there's potential good news on the grad school front.
Really?
I assume that's what you mean about coming.
Oh, no. I mean, I want to be there. As in, those are my plans. Like,
Okay.
no news on the grad school front so far. Actually, that's like all the more reason why I want to be there, because yeah, I'm really bored just sitting at home for months. I think it'll be better to work there in person.
Right. Let me let's look into that. So the other things we talked about with Liv is our spectra go further with Bob, I should say Bob, Liv, Gabe, and I. Our spectra go further to the red than their spectra. Their spectra go further to the blue. They go from 4,000 to 7,000, and we go from about 5,000 to 9,000. So is there more information on the red side that they are missing? It's the second question. Third question.
Yeah, it's possible. I don't remember off the top of my head if there are any broad emission lines.
Yeah, I don't. I don't remember either.
Yeah.
But even in the region of wavelength space where we overlap, which is from about 5,000 to 7,000, there's some good set of emission lines. We have a factor of 2 better spectral resolution than they do.
Oh, that's
okay. Now, like I said, this is just based on that 2011 paper. If they're more up-to-date spectra, then that may no longer be the case. When you have better spectral resolution, we can measure line shapes and widths better. So that's another interesting angle.
Yeah, and also I do remember that some of the broad emission lines are really close together. They show up really right next to each other. So that's probably one area where we could make some improvements. So yeah.
Could do better there. Because they are fiber spectrographs, they mix nebula emission lines with stellar lines, right? Nebula emission line meaning surroundings of the star. Whereas because we have a slit spectrum, we do a better job of sky subtraction and isolating the star.
Right.
And I bet this will show up when we plot one spectrum against the other. Like they show sulfur 2 lines from the diffuse ISM, and we shouldn't see that in our spectrum. But it's intriguing, they don't show nitrogen 2 from the diffuse ISM should have nitrogen 2, and they don't see that. So there's some intriguing
Yeah, that's
things like
interesting.
that.
I
Question we
don't
asked
know
is-
if,
Yeah.
sorry, I mean, they don't say that, or like they don't talk about it.
No,
Like
the spectrum doesn't show nitrogen 2, and we are intrigued by that.
Really, that's really interesting.
Unless it's blended with something, those are the things that we don't know yet.
See,
One more thing is Bob wondered whether we could get, there's a lot of information bluer than 4,000. So, oh, sorry, bluer than 5,000, shortward of 5,000.
right.
The question is whether we can get new Keck spectra of some of these objects with a different, not demos.
I see. Yeah, and a different wavelength range. Right.
Shorter wavelength range, higher resolution. And if we did that, then of course we could get this information not just for the bells, but for other stars as well, other Wolf-Rayet stars.
Right.
The final thing is, one or more of those bell stars may not be Wolf-Rayet stars. They could be unusual in other ways, and that would be interesting to ask. Bob was asking that, they point out that they see some unusual stars that are not Wolf-Rayet stars. Have we independently rediscovered some of those? That's an open question.
Right. I think we're talking about two confirmed Wolf-Rayets and our within our Bell's candidates.
Yeah, we should check because there's a list of coordinates. All we have to do is look at the coordinates, and
Right.
but also the coordinates have to match exactly. So we are thinking that looking at HST images and source catalogs around at least each of our 6 bells and maybe around each of the 200 Wolf-Rayet stars. These are things that the undergraduate student Gabe can start doing.
Right. I remember the last time we talked, we were talking about this cross-matching task, and yeah, the problem is that it has to match exactly, and the error will depend. It will depend on HST, and it will also depend on the source catalog.
Yeah.
So yeah,
All
that's
of
something
exactly right.
that
Now, the good thing is Wolf-Rayet stars are really bright. They're really luminous.
all right.
And such luminous stars are rare in any galaxy, including M33. So it may not be that difficult to uniquely identify which the Wolf-Rayet stars is.
Right.
Again,
Yeah.
we won't know because massive stars are also not born alone. They're born with other stars. So it would be interesting to look.
Yeah, like I said, yeah, that like we discussed last time. Yeah, there seems to be a bunch of Galax candidates for the Wolf-Rayeets, for some of the Bell subjects, not necessarily Wolf-Rayeets.
Yeah, doesn't surprise me. And we can go beyond Galax because Galax has very poor spatial resolution. With HST, we have 275 and 336W, which are in the ultraviolet. So they're better resolution, better than Galax in that sense. So that raises an interesting question, right? Suppose there are multiple massive stars very close together in the sky. If that's the case, it'd be difficult to identify which one is which, but it also means that the Nugent and Massey fiber spectra are not picking up the light of individual stars.
Let's see.
So at least identifying cases like that will be important, because if they have a 3 arc-second fiber and there are multiple massive stars within the fiber, then we're not getting the spectrum of a single star. They're not.
Yeah. I mean,
Of course,
yeah,
only
that
one
does
of them
make
has emission
sense.
line. We're still measuring the emission lines, okay.
Yeah.
Anyway, these are interesting directions. These are all the sorts of things we want to pursue next.
Right. Yeah, I think I need to sit down with Olive and yeah, because they did look up some targets in the other catalogs that could be potential matches, but yeah, I don't know.
Yeah, merging that information would be good.